So I do have this is a resistor, this is a coil, this is a cell of EMF E. At t equals 0, I'll close the switch. Then I'll write down I'll search for expression for current through the RL circuit here. So now in what direction the current I will flow? At t equals 0, I'll close the switch. I plus minus, I'm treating this like a circuit element. The current I will flow in this direction. Then writing loop equation plus E minus VR minus VL equals, you are moving from higher potential to lower potential. So fall in drop across the inductor also fall in drop. So further this I into R L di by dt. So what is we want expression for current I. So rearranging that, L di by dt. So di is equal to E minus IR dt by L. Let me adjust the quotient of I. L by R. Where this L by R, I'll give a specific symbol. I'll call that as time constant of circuit. This is called like a time constant of circuit here. So this will integrate at t equals 0. What was the current in the coil? 0. At an instant of time, let I be the current. So solving this, minus log of t by negative sign, I'll send on this side. So this will be log of E by R minus I by E by R. So this everything will become 1 minus I by E by R equal to e to power of minus t lambda. So look at now, current through the coil, it increases exponentially. Say why again, what is R? R is the resistance of the connecting wire or resistance of the coil itself. See, we never get a ideal inductor. What do you mean by ideal inductor? The wire which is used to make the resistance, the wire which is used to make the inductance should not have zero resistance. Not possible. So superconductor, superconductors cannot be molded in the form of like a wire, like a making a coil, making a spring. Not possible. We are not at reach to that level of technology. Hypothetical situations they'll bring it, but practically what happened, we don't have ideal inductor till date. We are unable to manufacture it because of the constraints, physical constraints here. Of course, in books we have hypothetical, like an inductor made up of superconductor. Because see, to bring superconductor, what you should do, you should create a conditions. No, they are not simple like a resistor inductor. Superconductor, what happened, has to be the total resistance will become 0. We have to bring magnetic field into the picture, all that one. So it's not that easy to construct superconductors of any arbitrary shape. Hypothetical problems will come, just you can manage that one. So now practically what an inductor will have internal resistance. You can call that resistance of the wire which is used to make inductor as this capital R, or resistance of a circuit. Either one you can take it. So basically, where do we use this inductor? Almost in all the electrical, electronic equipments. And what all we have whenever this fan, AC generator, this one, motors, water pumps, in vehicles, everywhere open, this inductor has come into picture. Like how resistor, capacitor are integral components of circuit. No, this is also one basic component. inductor is a basic. You take anywhere what pen, this will be present in almost all electrical and electronic circuits here. Now, when you switch on circuit, immediately the current will not become maximum. Though we are sending a constant current, what do you expect? There's a DC source, no? What do you mean by DC source? Current will be directed in one specific direction. Current will not alternate. So when I switch on, what do you expect? I won't expect. I thought current E by R will flow. No, the current will gradually increase. When it will be E by R? After a long time. When this like a, or you can call this as steady state current, or I infinity, I'll call it. Now what about the drop across inductor? I want the drop across inductor. We'll differentiate this. If I differentiate di by dt, I infinity by lambda e to power of minus t lambda. What is I infinity? E by r. What is lambda? L by r. This is value of di by dt. Now I know value of di by dt. So can I bring VL? So what is the drop across inductor? There's a breakup. I'll put arrows so that continue you can see it. No. What is the drop across inductor? What is the formula? L di by dt. We know value of L. We know value of di by dt. E by L e to power of minus t lambda, which is equal to e to power of minus t lambda. This is the drop across inductor. Look at the drop across inductor. It will decrease exponentially, no? At t equals 0 equal to e and exponentially decreases. And as usual, what is the drop across resistor? I into R. We know I. This will be E by R. Now make a careful observation. Drop across the inductor, drop across the resistor. So when I plot all the graphs, when I go for plotting of curves, the curve will be exponentially increasing one. And almost it remains, it becomes constant exponentially. It should be like this. This is the drop across inductor. What about the, sorry, the current through the inductor? We are first interested in current. And this is equal to that steady state current. And this is t is in seconds. So we'll define one time constant. What is the time constant? Time taken for the current to become 63% of maximum value. One time constant, lambda equal to L by R. So the time constant, will define it. This is lambda. How much it will become? It will become 63% of final value. So how you define time constant? Time taken for the current to become 63% of final value. That's called a time constant. So how do I obtain this? Take help of this equation. Put t equal to lambda 1 minus 1 by e. 1 by e, value of e is 2.7. If you calculate, we'll end up this equation. I'll derive all that here. So we know this is the expression for current at any time. So this will be E by R 1 minus lambda by lambda. which will become, this will become 0.63% of 0.63 by ER or 0.63 by I infinity. So time taken for the current to become 63% of final value. This I infinity is the final current that will flow through the circuit. Similar to RC circuit, steady state charge here, steady state current after long time. So when do we get current? Practically after 5 lambda, theoretically at infinity. Check it, put T equal to infinity, then only what pen will get I equal to E by R. Put T equal to infinity, then we'll get I equal to E by R. Constant current. But practical open after 5 lambda, the current through the coil will be almost constant. After 5 lambda, it will be constant. Practically. Theoretically, it should be infinity. And we define time constant, time taken for the current. So how you define time constant? Time taken for current through the coil to become 63% of, don't call steady state current final value. Final value we do, it all depends upon that one. No? So just call final value. There's a method of defining time constant. Now like this, if you check it now, almost theoretically infinity, practically after 5 lambda, it will almost become steady current. So this I infinity, I'll give a good name. I'll call steady state current. Again, I think we called it like this, no? 2 lambda, 3 lambda, 4 lambda. This is called like a transient state. This is called like a steady state. So tell me like in which particular state we'll be using inductor. Practically we'll be using here. Practical use. Here is what I'll be using. This is the unwanted transient state. Practically useful steady state. I am writing very directly in the graph itself. In which particular state will be using the inductor in application. I'll be using in this region. This unwanted one. So what do you want? This you want to be more or less. Unwanted you want it to be more or less. Unwanted online coaching classes. Do you want this to be continued till your final exam? No. This as early as possible. Practical classes as early as possible. Physical classroom. So there's unwanted. No, we don't want it. It should be minimized here. So tell me how to minimize this. Whose help I should take? The time constant. So what is a lambda? Lambda. So tell me like in a circuit when I design where there'll be inductance resistance. So what type of circuit I should prefer? L should be less, R should be more. Then the time constant will be less. Then immediately it will come to the practical stage. Practically you solve this one. Steady state is what we'll be using the inductor. This is the one basic idea of when you design means, sir, okay, what is L? See, sometimes wantedly you introduce L in a circuit. Unwanted inductance also will come. How come unwanted inductor? Any current carrying structure now will have inductance. I am making things clear. I just made you coil, but any current carrying structure will have inductance. Any current carrying structure means you look at a fan. In the fan, a separate inductors will be there, coils will be there. All of you know, winding of coils, am I right? And also what happen, we'll be using so many other conductors no, to construct that fan. So when any current flows through that conductor, will have inductance. So wanted, unwanted. The unwanted also, inductance is what will be troublesome. What we design is keeping the inductance of circuit, but unwanted current carrying structures, they'll bring this lambda, and unwanted conductors will have resistance. So this will be troublesome. We think that, okay, I designed properly, but the unwanted things happen. You didn't took care. And because of that happen, you switch on fan. After 5 minutes, it starts rotating. How you feel? big headache, no? You switch on water pump. After 5 minutes, it starts pumping the water. You switch on AC. After half an hour, it starts working. After half an hour, starts cooling effect will come into picture. It starts cooling. Any reason? Because of L, because of R, because of C. See, for working of circuit, I'll bring LRC, but unwanted LRC what happen will delay this transient state. So this should be minimized here. So therefore, when I'm designing electronic equipment, what I should see that these are called like a stray they call. What do you mean by? I think all of you very familiar with this one, no? Stray dog, pet dog. What do you mean by that? Stray dog, unwanted dogs, pet dog, your favorite, where you can feed like ordinary human being. Even some pet dogs, they're leading very luxurious life than human beings. So stray means what here? Unwanted, no? So this is what like that. The unwanted conductors there will have capacitance, will have inductance, will have resistance. And what they do, they will increase the transient state. So therefore, it's not just like a the design. So even along with the look, what will happen, you should take care about this one. It's I'm telling this one. The moment you become engineer, the error, this transient state, I'm telling this one, they are the best friends. The whole life will be there for you to trouble. You'll never be happy. You want to become happy, don't become an engineer. You want to be, if you want to be happy, no, don't become engineer. That's one. You want to be unhappy or to become engineer. Because whatever things you take, there'll be trouble. So only thing is you can bring only the percentage, not like exact. How best till 90%, 95%, 99%. That 1% again may trouble you. So this is what happens in the designing stage. Each and everything you have to take care. It's not that I'm telling this one, it's not that easy to become good engineer. Just to become engineer, okay, anybody can become. But really, if you want to become design engineer, no, the whole life will not be sufficient for you, because constantly you have to struggle with all these elements. We'll call this transient states, errors you have seen. So this was the troublesome life will be there for you. Okay, this is about the growth of current in RL circuit, everything there. So now let me go for a T equal to infinity. How do it will be circuit at steady state? Let me finish off this topic at steady state. Steady state means T equal to infinity after a long time. What about current to the circuit? Constant E by R. So where the inductor is there, I should replace with a short circuit. Clear this? This will be, will there be any energy in the coil? Yes, there will be energy in the coil, but current through the coil will be constant. The inductor, will there be any energy present here? Yes, there will be field energy. I'll just show it. Call that as U infinity. How do inductor? It will be like a short, where all inductor is there. And what is that red color? Red color things are the field energy. Or I'll just show some color. Some energy is present. The inductor you have to replace with a short circuit. Then what is I infinity? According to formula, I is equal to E by R 1 minus e to power of minus t by lambda after long time. E to power of minus this everything will end up with E by R. This I call steady state current. So what is the energy stored in the inductor at steady state? Of Li square, L by 2. I infinity is E by R whole square. So L E square by 2R square. So at steady state, what you should do? At steady state, inductor behaves as a short circuit. Okay, now after at steady state, what I do? I'll come back to this. At steady state, the switch is thrown from 1 to 2. I'll take this diagram. We'll paste it there. Where we are inductors.